everyone. Welcome to class number 7. In this class, we will discuss how we can connect three pieces in the same network using the concept of switching. So in the previous class, we were able to connect two PCs in the same network. Now in this class, let's try to connect three PCs. So let's say this is PC1, this is PC2, this is PC3. Let's say we want to put all these pieces in the same network. So here I want like to take 10.0.0/24. So to connect PC1 to PC2, we use a physical cable, and each end of the physical cable has to be connected to a network interface card. Okay, so let's say we have given this one .1 IP, this one we have given .2. So this is good. Now PC1 and PC2, we can establish the communication. So let's see how we can connect PC1 to PC3. So we need another network interface card, we need another cable. Okay, so same, you need, each computer should have two network interface card in this topology, right? And each one should have two different cables connecting to two sides. So the first problem with this type of devices, you need to have multiple network interface cards. So that is not a good way. For suppose if you want to connect 5 or 10 PCs, you need to have 5 or 10 network interface cards. So that's not a good design. Next, you need to have multiple physical cables. So this is also not good. So if you want to connect 5 PCs, each machine should have 4 connections to other 4 computers. So like this you cannot expand the network. So from the point of network interface card and physical cables, it's not easy to expand the network like this. Another issue is when you try to give, so you need to give this interface also in the same network. For suppose you try to give it .3, this system won't allow to have the .3 in any of the network interface card, because already another network interface card already has it 1/24. That means in this /24 network it already have .1 IP. If you try to give another IP in the same network, this PC won't allow it because it will have a conflict. Okay, so this is not even possible. So there is no way we can put all the PCs in the same network with this design. So that's why there is a network device called switch came into picture to resolve these issues. So let's see how switch works. So we have taken three PCs and we have given the IPs .1, .2 and .3, and we connected each PC to the switch. So switch or any other network device, it will have multiple network interface cards. Okay, so because the purpose of any network device is to connect multiple devices, so having a single network interface card, it's not possible. So that's why any network device will have multiple network interface cards. So in this case we connected it to Ethernet 1. So this is the network interface card name on this switch, and another network interface card name is Ethernet 3, Ethernet 2. So the names are different from product to product, the network interface card name, but basically these are all network interface card, and generally we call it as ports. Okay, so from PC1 network interface card, we have a cable going to Ethernet 1 port on switch. For PC2 we are connecting to Ethernet 3 or port 3. For PC3 we are connecting it to port 2. So on the PCs we have configured the IP for that network interface card, but on the switch you don't need to configure any IP address. Okay, so there is no need to configure anything on the switch with the default config. So let's say we try to ping PC1 to PC3. Okay, so PC1 will send a packet and it will go into this physical cable and it will reach the switch. Now switch has to process this packet. So once it receives the packet on one interface, all it needs to do is it needs to switch that packet to the target device. For suppose PC1 is sending a packet to PC3. Once it receives on the Ethernet 1, it just needs to move that packet and send it out on Ethernet 2. Okay, but how switch will know that PC3 is behind Ethernet 2? Okay, so let's see. Any switch will have a table called MAC address table. Okay, so basically in this table you can see MAC address column, type and ports. There are two ways we can tell a switch which MAC address is behind which port. So one way is static. Static means administrator must configure the switch specifying that okay, this specific MAC address is behind this port, but this is not the case in real time. 99% switch will learn or configure to learn the MAC addresses in a dynamic way. So let's see how it will learn. So if you can see, now this MAC address table has empty. There are no entries. After PC started communicating, switch will dynamically learn MAC addresses. For suppose this is PC1 MAC address, so it learned that MAC address is behind this interface Ethernet 1, so it is matching with our topology. And this is PC2, we connected it behind Ethernet 3, and this is PC3 and it was behind Ethernet 2, so it has learned some time back. Also these entries will not like permanent. Okay, there is some time value, depends on the switch type and switch product. So let's see how switch will populate that MAC address table. For suppose we have PC1 here. Okay, when we try to ping PC2, what will happen in the beginning? In order to send the ping packet, first PC1 should know the MAC address of the PC2 10.0.0.2. For that, what it will do is it will create a ARP request. Basically ARP request looks like this, right? Source MAC address will be PC1 MAC address, destination will be all F's because PC1 doesn't know the MAC address of PC2, so it will use this address to send the packet to all the devices in the same network. And inside the packet, the question is who has 10.0.0.2. Okay, so once this comes into the cable, it will travel and reach Ethernet 1 on the switch. So imagine like that switch is a room, has multiple doors. Okay, so this is door 1, let's say this is door 2, and this is door 3. Okay, so if a packet comes from, for suppose let's say PC1 is behind door 1, PC2 based on the topology it's behind door 3, PC3 behind door 2. So when PC1 send this packet, it is coming on door 1. First what switch will do is it will see the MAC address. Okay, source MAC address. So if a switch receives a packet and it has source MAC address of something, then that means whoever sending that packet behind that door. So what it will do is it will add it to the MAC address table saying that okay, behind door 1 I have PC1. Okay, so this will be added into the MAC address table. So whenever the switch receives any packet with destination MAC address of PC1, it will simply send it through door 1, because it already learned that when PC1 send packet, it learned that this MAC address is behind this door 1. Similarly, if any packet comes on any door, it will look at the source MAC address and will note down that that particular MAC address is behind that door. Okay, so that's how MAC address table will build. Okay, so let's see what kind of packets will come to the switch and what exactly switch will do. So this is the ARP request it might receive when we try to PC1 to PC2. So this is basically a ARP request, means it has to go through all the machines in the same network. So when a switch receives a packet, it needs to forward it, right? It doesn't need to keep it on its own, right? So it needs to forward it to some another interface or port or network interface card. So in this case, it is a broadcast MAC address. So switch, what it will do, it will send it to the all the ports except where it is received from. In this case, it is received from this side, so it will send it to here, and if you have multiple cables and multiple PCs, it will send it to all the ports, because this packet needs to be sent to all the ports in the same network, because this is a ARP request and it's a broadcast. Okay, so the first point is switch checks the destination MAC address and looks up again at its MAC address table. If it finds the entry, forward the frame to the port based on the MAC address entry. If it does not find the MAC address in the MAC address table, or if the destination MAC address is all Fs, it will forward all the ports. So in this case, it will match this condition. Okay, so the ARP request will go to PC3 and PC2, and for this particular request only PC2 will respond because it has 10002. Then it will respond back. Once it comes to the switch will learn that based on the packet, this packet has the source MAC address of PC2. Then the switch will know that okay, PC2 is behind Ethernet 3. First it will add that into that. Okay, so checks the source MAC address and adds it into the MAC address table. For suppose when we receive the ARP request, it noted down that behind Ethernet 1 we have PC1 MAC. Okay, so when the ARP reply came in, it do the same thing. It checks the source MAC address. In this case, source MAC address will be PC2 MAC address, and it will add it to the MAC address table entry stating that Ethernet 3 PC2 MAC. Okay, so once it comes here, it needs to forward this ARP replay packet, right? So to what it will do is it will check this packet destination MAC address. So in this case, destination MAC address will be PC1. So it will send this way, Ethernet 1. So when a switch receives a packet with the destination MAC address of all Fs, it will send it to all the ports. There is another scenario as well. When the switch doesn't find a MAC address table, for suppose you have some specific MAC address, let's say 6805 ending with. If the switch doesn't find any entry in MAC address table, what it will do is, in that case also it will send it to all the ports, because switch hasn't received any packet so far with the source MAC address as this one, so it won't be able to add it to the MAC address table entry. So this type of packet we can call it as unknown unicast, means we don't know where this particular MAC address is. So before we make any ping communication between PC1 and any other PCs in the same network, the MAC address table is empty. Once I did the ping test to .2 and .3. Now you can see switch dynamically learned that Ethernet 1, behind Ethernet 1 it has this MAC address, behind Ethernet 3 this MAC address, Ethernet 2 this MAC address. So based on this MAC address table, if a switch receives any packet, it will look at the destination MAC address. For suppose if it receives a packet with the destination MAC address of 6801, it will simply switch the packet to Ethernet 3. So in this case 6801 is PC2 MAC address. This is 6802. This is 6800 in this topology. So when switch receives a packet with the destination MAC address of 6801, it will just push it to Ethernet 3. Okay. So how it was learned that 6801 is behind Ethernet 3? This entry is populated because sometime back PC2 might send some packet this way. When it sends some packet, it will have source MAC address as 6801. When switch received the PC2 packet, it added that entry to the MAC address table. So that's how this entry is populated. Okay. Similarly, other entries as well. So to summarize, switch looks at the destination MAC address to forward the packets. Okay. So it will only look at the destination MAC address to identify to which port it needs to forward the frame. It is not looking at the any IP address field. Okay. It is only looking at the MAC address. And switch did any changes to the packet? No. It did not do any changes to the packet. It just packet came in one port and it just forwarded to another port. Okay. So if the packet comes here, it will just send it here based on the MAC address table. So how switch will learn that which MAC address is behind which port? When a packet comes on one port, it will check the source address and it will understand that okay, so if this source comes from this direction, then obviously behind this port this is the MAC address of the device. Okay. So that's how switch will learn and forward the frames. So assignment for this class is build similar topology in GNS3 lab and verify ping connectivity between PC1 to PC2 and PC3. You can take any type of IP address, so prefer to take class A, B, C private IP address, but keep the IPs in the same network. You can take any of them and verify it on the switch, the MAC address table, to make sure it has learned the MAC address table properly. Okay. Yeah, that's all for today's class.